Alright, so this is going to be a video on what's called the disk method. And basically what the disk method is it's used to find the volume of a solid formed from rotating a function around an axis. Okay, so there's a lot to break down here, so I'm going to kind of show you this using an example. So again, it's the volume of a solid. This solid is called the solid of revolution because you're actually going to be rotating it around a certain axis. Okay, so say we had some function right here, like this blue function right here. So I have a linear function and I wanted to rotate it around this x-axis. You can see this arrow right here. So I'm taking that function and I'm rotating it around this axis right here. Now if you can imagine the solid that's being formed as it's going around this axis, it's going to look something like this. It's almost like a cone with the first part of it kind of just cut off. Okay, so if you can imagine that, it takes a lot of spatial intelligence to kind of see that as you're rotating it around, it forms this. But that's basically what that solid of revolution means. You're just taking a function and you're revolving it around an axis. Alright, so you have a solid like this. What happens if we wanted to find the volume of some solid like this? Now this might be easy to do the old geometric way and use the formula for whatever shape this is, and you can easily just measure it and figure out the volume that way. But we want to be able to try to figure out this volume of this solid of revolution using calculus. That way I can just put any function in here regardless of how curvy or crazy it is and still be able to figure out the volume of it just based on whatever this function is. So that's what we're going to do now. So in order to do that, the first thing that you're going to want to see is that what this shape forms is really just a bunch of circles that are basically side by side. So if you can kind of act like you're just slicing this thing up, you can imagine there's a circle here and then there's just another bigger circle to the right of it and it just keeps getting bigger and bigger and bigger. So it's basically a stack of circles that are just side by side right here to form this shape. And that's kind of how we're going to find the volume of this shape, is we're going to add each one of those individual areas of those circles up, and it's going to equal the volume. So the volume of this solid of revolution is going to be as follows, and this is basically what disk method is. So it's going to be V is equal to, well, we need to know the area of each one of those circles. So we're definitely going to need pi r squared for each one of those circles. Now we're adding them up from a certain interval, in this case A to B. So that means we need to integrate from A to B these circles, because we're going to be adding up all those individual areas in between as it's rotating around. Okay, we're doing this all with respect to x because we're going on the x-axis. Okay, you can do this exact same thing if you want to revolve around the y-axis, but then you're just going to have to change that dx to dy. Okay, we're going to talk about that a little bit more later. Okay, from here we're going to simplify this a little bit more to get this r in terms of x. Okay, so what I'm going to do is rewrite this. This pi is constant, so I'm actually going to put it in front of the integral. If you remember our integral properties, we are allowed to put constants in front of the integral. So we're going to end up with pi, and then it's being integrated from a to b. Okay, this r, we want it in terms of x. Well, what this radius really is the distance from this y equals 0 all the way to this whatever this y value is here. So it's going from here all the way up to here, and that's the radius that you're going around. So the radius of this circle from basically the center right here to this is going to be based on that y value from 0 to whatever this is right here. So this y value is based on this f of x. So whatever the x is, that tells you what the y is for this function. So instead of using r, we're just going to put in f of x and square it because the r is squared as well. Okay, then I'm just going to multiply by the dx right here, and we end up with disk method. This is the equation to figure out the solid of revolution of any function that's going around some interval from a to b. Okay, all you'd have to do is take whatever the function is, square it, integrate it from a to b, and then multiply it by pi, and then you end up with the volume for that solid of revolution. On a related note from disk method, there is another concept that's related to it called the washer method. And basically it's called a washer method. If you know what a washer is, it basically looks like a metal donut, and it's used in a lot of machinery to kind of hold bolts together a little bit easier. So it's basically, instead of calling it washer method, you can think of it like a donut method. And basically it's the same thing as disk method, where you have a bunch of disks that make up a certain shape, but there's some absence in the middle of it, some part where it's just completely empty. You can imagine another function. Just say I have another function right here. Okay, let's just call this g of x. And this is being rotated around the axis as well, but that's going to indicate the empty space that I have in this shape. So it looks like you're going to have some inner cone here that's basically going to be empty. So I'm going to try to draw that in right now. So we basically have something that's a little bit lower. Okay, so if you can kind of imagine that shape, there's basically an emptiness in the middle of it. So it's the same shape that we had before, only there's some emptiness in the middle of it. So what we're going to do is we're going to have to employ the washer method to figure out the volume of this now, since obviously it's going to be a little bit less. Now since it's going to be a little bit less, you're going to subtract off that inner volume right here to figure this out. So it's going to look something like this. So you're still going to have the volume from the disk method for that outside function, the function that's like above it, but this time we have to subtract off that inner function. So this is called washer method, and again, we're just going to be subtracting off that inner volume. So we're going to take that volume that we have for the disk method, so I'm just going to rewrite it. V is equal to pi times the integral from a to b of f of x squared. And what you're going to want to do is just subtract off that inner function. So in this case, it's our g of x. So I'm just going to subtract off that g of x squared as well. And you end up with the washer method. So basically it's the same thing as disk method, you're just subtracting off another part of the volume to kind of make up for that empty space that we kind of took out from this shape. So that's disk method and washer method. If you have any questions about anything in this video, let me know.